bit of software that turns one of these SDR dongles you've all heard about, microphone, one of these guys into a cheap Entropy source. So I start off with a bit of an intro into page down, up, down, left, right, space. Oop. So a bit about software-defined radio. Who knows what that is? Lots of people? Good, I can skip that one. But yeah, basically with standard radio you get an antenna, lots of complex things that I have no understanding of, and some output. With software-defined radio you can have an antenna, a little bit of electronics, and the rest is in software, which I know a bit more about. So that's where you get the bits in and out, is from this thing called a quadrature sampling detector, which you guys probably could build one in your sleep. But it gives you the full information you need from a signal with the in phase and quadrature, so that's the in phase and 90 degrees out of phase, I think, but it gives you the direction in complex phase space of the signal you're receiving. So what I like about SDR is, it's maths, right? It's maths, and maths and electronics are equivalent, so that's how you get FM, stereo FM, and that's what it looks like as a circuit, which is pretty cool. And that's what it looks like as code, which, yeah, it's much more easy to understand, isn't it? So you've heard about these things. A dude found that the DVB T dongles that do DAB+, some of them you can turn into a quadrature sampling detector with a bit of bandwidth. So I've got it there, 3 megahertz of bandwidth approximately, 8-bit sampling, 3.2 mega samples per second, if that means anything more to you guys than it does to me. There's a bunch of software around, like GNU Radio is the big one. It's massive and has everything you'll ever want to do, just about. It's got all the stuff B-Dale was talking about before, and Keith.
You mean it's like Emacs?
It's kind of like Emacs, yeah.
At a certain point you can drag and drop decoders onto a page and build your own decoder from pieces like Lego. Exactly.
And so people have done things like DVB-T decoding in software radio with GNU Radio. In 1999, I think it was. 2009. It didn't quite work in real time, but it was close. So you guys know about Entropy. It's lots of maths, and there's some Wikipedia links. And if a data sequence has high entropy, if you can't tell what the next bit's going to be given all the previous history, that's all you really need to know about it. Various sources of it. These guys obviously are sampling atmospheric radio noise, or you short the antenna port, put it in a sealed box, and you start sampling the electrical noise of the amplifiers, which is a bit more secure. I'll just say I did this at a different place because I don't know if you guys have a 2 gigabit per second quantum vacuum noise thing here, but this was at ANU, which is pretty cool. That costs, I think it was on the order of $1 million to build one of those. Whereas this thing, you can get about 5 megabits a second for $30, which is pretty cool. So my software samples, it takes the 6 least significant bits that come out of the ADC here and spits it through some debiasing, and the FIPS 142 tests, which you may not want to trust anymore. And since I've written this, I've done some other bits. So it doesn't just XOR. In fact, I might even, it does the Kaminsky stuff as well. Yeah, there we go. So these slides are a bit old. But yeah, so Kaminsky debiasing changes the input dramatically if one bit differs on the output dramatically if one bit differs on the input, which is what you want if someone's trying to spam your sampling bandwidth with high levels of predetermined noise. And if they have to know exactly the characteristics of your ADCs and your quadrature decoder to get the same output as you. What else did you want to see? So yeah, you can get the amplifier noise, which is much harder to mess with. And so when I did this, it was, what do I need to do next? But I understand Kaminsky debiasing a bit better now. And so yeah, that's all that. And yeah, do you trust me to get your entropy right? So my code's up on GitHub if you want to look at it. Any questions?
Does it stir the entropy that the kernel provides, or is this entirely?
This provides a bitstream in user space. So you can...
Dump it in dev random or something like that.
So you use a thing called RNGD, which comes with the RNG tools, on Debian at least, that can read from a variety of sources, including a FIFO, and that mixes it into the kernel. You could also do it with the, I forget what the system call is, but there's system calls you can use to pump it in directly. I haven't done that yet. I'll get there one day. Go for it.
Where does this fall into the thing where you should never write your own crypto?
Yeah, you should never write your own crypto. So this is the basis of all your crypto, right? So all crypto needs random numbers. So and this generates random numbers. So if you don't like what I'm doing, you don't do it yourself. Pay someone else to do it, I guess.
So you add it as one source of entropy, you don't use it as your own source of entropy?
Correct, yes. It's always good to mix multiple sources, particularly after they've been checked by something like FIPS, but whether you trust FIPS or not is another thing up the back.
You check yourself with FIPS. Is there a physical indication that you've failed the test? You kind of, oh look, the red light is on, I shouldn't trust it?
Well, yes, I spit out the errors as they come in. My code does. It's not a physical light, it's just code. And it prints an error saying, this block failed, and just tries the next block. You get blocks failing with real random number generators, like the quantum noise one. It'll still fail tests every now and again because they're only statistical tests. There's no deterministic way of saying, yes, this is entropy.
If you didn't, it wouldn't be random.
Exactly, yeah.
What are you using these random numbers for?
Nothing at the moment, but people
Adding entropy to the world.
just, yes, increasing the temperature of the Earth a bit more. But there's a couple of companies actually using my software now, which was a bit strange for me. I wrote it because it was cool and people find it useful. It's the first time that's ever happened to me. And thank you. So yeah, I've been supported by Star-to-Star Communications to write this software, and Blade RF guys at Newand have sent me one of their peripherals. I haven't got it yet. It's at work back in Canberra. But that can do 30 mega samples a second as opposed to 3, and it's 12-bit ADCs instead of 8. So
It's also a lot more expensive.
yeah, $400 versus 30.
As opposed to $1 million for the other one.
Well, yeah, but yeah, $1 million. So that, I think I should be able to get about 40 megabits per second of entropy out of the Blade RF, which in computer science terms is huge. You'll never need that much, right?
640K ought to be enough.
Yeah, well, yeah. Unless you, like, things like if you ran all of Amazon's connections at once using SSL, you'd probably use up 40 megabits of entropy. Anything else?
Generate a whole lot as well.
Yes.
That's what they use dev random.
Yeah, I mean, you use dev random because it doesn't block. And it goes into pseudo-random numbers eventually when it runs out of real random numbers. Yeah, that's a lightning talk. There you go.
Thank you very much.